All right, how's everybody doing? Hope you're doing good today. Sorry I can't be here today, but I did make this video to kind of go over the answers from your homework. So hopefully that you've, after you've had 15 or 20 minutes to kind of talk that over with some people in your class, we're ready to go. Okay, so here's number one. It says, let S be the shaded region in the first quadrant, bounded above by the horizontal line y is equal to 3, below by the graph of y equals 3 sine of x. So that's this part right here. And the vertical line x equals to k, which k is right here. And in this problem, k is going to change a couple of times. In fact, it's going to be 3 different values for each of the 3 different parts of this question. So the first part says find the area of S when k is equal to pi over 3. So for area in this particular problem, this is definitely going to be a top minus bottom situation. Okay, so when I do the area, obviously I want to take an integral. In this case, I want to do dx because, as I said just a second ago, it's going to be top minus bottom. My lower bound is given in the question. The question says that k is equal to pi over 3. Okay, so this k value right here is currently equal to pi over 3. And then my upper bound is whatever the intersection point is right here between the line y equals to 3 and y equals to 3 sine of x. So I'm just going to set those two things equal to each other. Okay, remember this was a non-calculator problem, so hopefully you didn't use your calculator on this particular question. I'm going to divide by 3, so I get 1 is equal to sine x. And now I need to know which angle gives a sine value of 1. Okay, and hopefully we all know at this point that that is pi over 2. Okay, and then finally, we want to do top minus bottom. So the top part of this region is the line y is equal to 3, minus the bottom part of this function is the 3 sine of x. Okay, since it's non-calculator, we have to do this by hand, so our antiderivative is going to be 3x, and then the antiderivative of negative sine of x is positive cosine of x. So plus 3 cosine x evaluated from pi over 3 to pi over 2. Go ahead and plug in your upper bound, so that's going to be 3 pi divided by 2 plus 3 cosine of pi divided by 2 minus, I'm going to put parentheses so that both of these terms get subtracted, 3 times pi over 3, and then plus 3 cosine of pi over 3. And this is a perfectly acceptable way to leave your final answer. You don't actually have to evaluate those trig values. Okay, if you do and you accidentally do it wrong, then that's obviously going to cost you a point, but it's okay to leave it like this. If that really bothers you, then you can go all the way to the final answer, okay, which is pi over 2 minus 3 halves. Okay, and you can check that for yourself, or if you don't want to, then just go ahead and leave your answer just like this, and that's going to be perfectly fine. Okay, part B is probably the hardest part of this question. It says that the area of S is a function of K. So what that means is that as K changes, the area of S changes. And I think that should make sense to you, because if we made K go this way, right, and made K a bigger number, then the area of this S is going to be decreasing. Okay, so the area of S is a function of K. And the question wants us to find the rate of change. Okay, well, I know that rate of change means the derivative. So they want me to find the derivative of the area of S with respect to K when K is equal to pi over 6. So the first thing that I better be able to do is I better be able to write the area of S as a function of K. All right, well, if K is any value between 0 and pi over 2, then the area of that region S is going to be the area from K to pi over 2 of the same integrand that we had on the last part of the question. Okay, so here's my function for the area of S as a function of K. Now, I want to take the derivative of this. I know how to take the derivative of an integral, or at least I should, and whenever I do that, remember that this upper bound has to be, this variable has to be the upper bound. Well, in order to make that happen, that means I just have to make this integral negative, make that constant pi over 2 the lower bound, and make the variable k the upper bound. And the integrand is not going to change. It should say 3 minus 3 sine x dx. Okay, so now if I take the derivative to find the rate of change, a prime of k is going to equal, I'm just going to take the k and plug it in for the x right there. So that's going to be 3 minus 3 sine of k, which says sinc. Kind of funny. Okay, so a prime of pi over 6 is what they want the rate of change at. So that is going to be 3 minus 3 sine of pi over 6, which is a perfectly fine way to leave your answer. Or you can go all the way to the final answer, which I believe should be 3/2. Negative 3/2, actually. Why is it negative 3/2? Because I forgot my negative sign. That was in front of the integral. So please be careful not to do that like I just did. The negative from when we switch the bounds of integration should stay with the problem for the entire time. So this should also be right here negative. Sorry about that. Okay, part C is just a standard revolving about a line, so a standard volume of solids by revolution problem. This time K is equal to pi over 4, and we are revolving about the horizontal line, y is equal to 5. So up here is y equals to 5 above the region. Okay, so definitely a washer problem. You guys just got done doing this on your test, so hopefully by now we're feeling pretty confident about these. So here's my outer radius. My outer radius is going to be 5 minus 3 sine x, since that's the function that line is hitting on the bottom. I'm going to square that, minus my inner radius is going to be from the axis of revolution to the line y equals to 3, and the distance there is just 5 minus 3 squared. I am doing dx here because the axis of revolution is horizontal. Okay, I'm going to integrate. I'm going to put pi since it's a revolution problem, and then k was pi over 4 in this particular part of the question, and the upper bound is pi over 2. Okay, so there it is. You don't have to evaluate it. This was a non-calculator question, so it'd be pretty tough to evaluate that by hand, and so they just ask you to write. Okay, here's the second problem on your homework. This was actually on last year's AP test. This was by far the hardest question. I think the average score out of 9 points was 2.5. My students were able to manage to average 3.3 points on this problem. And there's probably going to be one like this on your AP test. There's going to be a problem that's out of left field that you don't really understand what to do, and that's okay. You are going to at least have the tools to be able to answer the question, as we're going to see on this one. You have all the tools. You just need to be able to apply those concepts to be able to answer maybe a question that you feel is abstract. Okay, so it says the inside of a funnel of height 10 inches, so the height of our funnel is 10 inches from the top to the bottom, has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by that equation. The units of r and h are in inches. Part A, we want to find the average value. Okay, well, I know the formula for average value. We want to find the average value of the radius of the funnel. Okay, well, my interval here is given by the interval on the height. So that says from 0 to 10. So my 1 over b minus a in this problem is going to be 1 over 10 minus 0, and then the integral from 0 to 10. And if I want the average radius, then I have to integrate the function for radius. So that's going to be 1 over 20. 3 plus h squared dh, which is really, really crooked. Hopefully you can turn your head and see what's going on. Okay, so this is going to be 1 over 10. I'm going to go ahead and move the 1 over 20, the constant, out into the front of the integral. See if I can straighten things up here a second. Integral from 0 to 10 of 3 plus h squared dh. Okay, So this is by hand, so I have to be able to do this by hand. This is going to be 1 over 200. The antiderivative of 3 plus h squared is going to be 3h plus h cubed over 3. Okay, evaluated from 0 to 10. So this is going to be 1 over 200 multiplied by 3 times 10 plus 10 cubed over 3. And then notice when I subtract and plug in my lower bound, I get nothing. Okay, so it is perfectly fine for you to leave the final answer in this form. Okay, and I would definitely suggest doing that. Okay, part B is the part of the question that kind of threw everybody off. It says, find the volume of the funnel. Well, there is no formula for the volume of a funnel. You just have to use concepts that you know about volume. And kind of the key terminology in this question is that it tells you that the funnel has circular cross sections. Okay, and I know that the integral from A to B of the area of a cross section is going to give me the volume. Okay, so the volume of this funnel is going to be the integral from A to B of A of x dx. Okay, well in this case, also in this case, we're going to need pi because the area is, the cross section is a circle. So pi integral from 0 to 10. Okay, my integrand is just going to be the radius. Well, I know what the radius is. They tell me what the radius is. The radius is right there. Okay, and remember that if the cross section is a circle, then that means I have to do pi r squared. So that's why I have to square my radius in this case. Okay, so just do some cleanup here. This is going to be pi over 1 over 20 squared is 400. Integral from 0 to 10 of 3 plus h squared dh. Now remember, this is by hand, so you have to think about how can I integrate this? Well, it's not a u substitution problem because u would be 3 plus h squared, but I don't have the derivative of that anywhere in the problem. So what I have to do here is I just have to square out that integrand so that I get what? 9 plus 6h squared plus h to the 4th dh. Okay, so remember that that's always an option to you. You can always just square out the integrand and then kind of go from there. Okay, so now down here I'm going to take the antiderivative. Don't forget to keep this pi over 400 around. The antiderivative of that is going to be 9h plus 2h cubed, and then plus 1/5 h to the 5th, evaluated from 0 to 10, okay, which is equal to, pretty much done at this point. I just need to plug in my upper bound. Okay, so let's see here. What is that going to be? 9 times 10 plus 2 times 10 cubed, and then plus 1/5 times 10 to the 5th. I would definitely not recommend doing any of the arithmetic there. When you subtract and plug in your lower bound, everything just zeroes out. And so there is your final answer. Okay, so kind of a tough question. You didn't really probably ever do a problem that said find the volume of a funnel, but that doesn't mean that you don't have the skill. Okay, last part of the question here says the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals to 3 inches, the radius is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Okay, well, I know that the radius given to me in the problem is 1 over 20, 3 plus h squared. Okay, that's given to me in the question. So if I want to use some of this information they gave me, first of all, what did they give me? They gave me that h is equal to 3. They also gave me that dr dt, the rate of change of the radius, is negative 1/5. Okay, you need to think about why is it a negative 1/5. Okay, there's your answer right there. It says that the liquid is decreasing. The radius is decreasing at a rate of 1/5 inch per second. Okay, and what are we looking for? We're looking for the rate of change of the height, okay, of the liquid. All right, so if I take the derivative with respect to time, this is a related rates problem. So dr dt is equal to 1 over 20. The derivative of 3 plus h squared is going to be 2h times dh dt. Okay, plug in what we know. So we know that dr dt is negative 1/5. This is equal to 1 over 20 times 2 times h, which we know is 3, dh dt. Okay, do however much cleanup you want to do there. And just some basic algebra is going to give you the final answer that dh dt is equal to negative 2/3. And this would be in inches per second if they asked you to put a unit. Okay, so there's the end of the answers from the homework. And then here in a minute, you guys will start your notes over in and out problems.